Right? You remember this result? Key the diagonal, the body diagonal of a cuboid is root length square plus breadth square plus height square. Okay, so this is like an extension of your Pythagoras theorem for 2D rectangles. Okay, it's an extension of that same concept into 3 dimensions. So instead of root length square plus breadth square for a rectangle, is root length square plus breadth square plus height square for a cuboid. Okay, all right. Then so today we're going to start working in how to convert from coordinate form to polar form and then vice versa in 3 dimensions. All right, so coordinate form, remember, that's the one which we used to write in terms of I cap and j cap. Since now we're going to work in 3 dimensions, we write it in terms of I cap plus j cap plus k cap. Converting to polar form just means finding its magnitude. Okay, so converting to polar form means basically finding its magnitude, probably finding a way to define, finding a way to define those angles. Okay, so now let's consider a vector. In fact, let's take this as our x, y, and z. Okay, again, remember, this is not in the same plane. These are 3 mutually perpendicular axes. All right, one is going towards the right, one is going upwards, one is coming towards you. This is just a 3D rendering of that. This is just a 2D rendering of that situation. Okay, one is right, one is up, one is towards you. Towards you को ऐसा draw किया है just to fit it on this fit it in the screen. हमने draw किया, but technically these are all mutually perpendicular. Now, if I have a vector given in this form, ax I cap plus ay j cap plus az k cap. Okay, you may have, as you were solving questions from your booklet, you may have seen something like this somewhere or the other. 2i cap plus 3j cap minus 1k cap, है ना, देखा होगा. So what do we do with this? How do we make sense of this? First and foremost, it looks like the addition of 3 vectors. So how do I make sense of the addition of 3 vectors? I should apply polygon law. So I have to add them. What does polygon law say? It says join everyone in a chain, in a head to tail fashion. So I'm going to draw my first vector ax I cap, which is basically a vector of magnitude ax along my x-axis. So you can see that pink vector, that's our first vector, ax I cap. The next one in the chain, join head to tail with ax, is ay j cap. So ay j cap is a vector of magnitude ay along the y-axis. But I need to join it head to tail with ax I cap. So I'm going to slide this guy and I'm going to draw it over here. Got it? So that's your ax I cap and this is your ay j cap so far. Similarly, the third vector is az k cap. So az k cap is a vector of magnitude az parallel to the z-axis. But again, I need to join it head to tail to apply polygon law. So I'm going to drag that and again, I'm going to draw it over here. Az k cap. So right now, do you see that ax I cap, ay j cap, and az k cap are all joined in the head to tail fashion? दिख रहा है? ये 3 को join किया. What is the resultant going to be? The resultant is going to be the vector going from the available tail to the available head. So my available tail is over here. My available head is over here. Okay. In fact, if I were to draw a parallelogram, sorry, if I were to draw a cuboid with ax I cap as the sides, A by j cap as, again, these sides, the vertical sides, and AZ as these sides. I can construct this kind of cuboid. I hope you can imagine that. So in that cuboid, our resultant now is going to be the vector going from this available tail to this available head. Well, my resultant is going to be the body diagonal of that cuboid. So A bar is actually this vector that I've highlighted, and A bar ends up being the body diagonal. A bar ends up being the body diagonal of this cuboid. So if I want to find the magnitude of A bar, all I need to do is I need to find the length of that body diagonal. How do I find the length of the body diagonal when the side lengths are AX, AY, AZ? I'll need to apply Pythagoras theorem, and I'll get the length of my body diagonal, or the magnitude of A bar, is root AX square plus AY square plus AZ square. Okay, so this was the derivation, but now just in the end, okay, I'll explain once more. देखिए एक और बार, यहाँ पे क्या है, यहाँ पे तीन वेक्टर है, AX I cap, AY J cap, AZ K cap. इनको मुझे ऐड करना है. Okay, so I am drawing a vector of magnitude AX along my x-axis, that is AX I cap. I'm going to add to that AY J cap, a vector of magnitude AY parallel to the y-axis. Remember, we are applying polygon law, so everyone should be joined head to tail. Then I'm going to add to that a vector of magnitude AZ parallel to the z-axis. हो गया AZ K cap. तो ये हो गया, ये तीन वेक्टर joined in a head to tail fashion. Polygon law क्या बताता है? The resultant is the last vector going from the available tail to the available head. So this vector is my resultant. Now, if I were to actually draw a cuboid with this as the length, AZ K cap is the breadth, AX I cap as the length, AZ K cap is the breadth, AY J cap is the height. If I were to draw such a cuboid, this you'd find would end up being the body diagonal of the cuboid. A bar would end up being the body diagonal of the cuboid. Now, how do we find the length of the body diagonal? We just saw this. To find the length of the body diagonal, you have to perform root length square plus breadth square plus height square. Length is AX, breadth is AZ, height is AY, root AX square plus AY square plus AZ square. Did you get it now? समझ में आया कहाँ से आया? This is a derivation. ये once and for all prove कर दिए हैं. इसके आगे whenever you want to find the magnitude of this vector, just apply Pythagoras theorem. Just perform root of इन तीन चीज का स्क्वायर का सम. Root of इन तीन चीज का स्क्वायर का सम. Okay. Recording of calculus lecture, please ask your center manager. You have a center manager, please ask them. Okay. Okay. And my recordings will go on the drive. जिसका link you have. So A is the body diagonal as well as the resultant side of the polygon. Yes. Yes. A bar is the resultant. It also forms the body diagonal in this case. It is also one of the body diagonals of this polygon. Is the head of AY J cap available? No. Why is the head of AY J cap not available? समझो ना what I mean by available. Can you see that AY के head पे हमने AZ का tail place किया? Hence that is not available. दिख रहा है? AX के head पे AY का tail place किया. AY के head पे AZ का tail place किया. Alright, so AY is somewhere in the middle of the chain. The final head that is available is AZ's head. Alright, so this is how we find the magnitude of this vector. फिर they also sometimes ask us to find a unit vector parallel to a bar. a bar के parallel unit vector निकालना है, ठीक है. So that's also going to be very useful. अब कैसे निकालना है unit vector parallel to a bar? First of all, it will get the name a cap because it's parallel to a bar. And the way to find the unit vector is divide the vector by its magnitude. वेक्टर से उसका मैग्नीट्यूड हटा दो तो यूनिट वेक्टर मिल जाएगा. कैसे हटाना है मैग्नीट्यूड? डिवाइड करके. तो अपना जो वेक्टर है ए बार, विच इज दिस वेक्टर ए एक्स आई कैप प्लस ए वाई जे कैप प्लस ए जेड के कैप, उस वेक्टर को उसके मैग्नीट्यूड से डिवाइड कर लो. मीन्स डिवाइड ए एक्स आई कैप प्लस ए वाई जे कैप प्लस ए जेड के कैप, डिवाइड दोस टर्म्स with whatever magnitude you find over here. Root ax square plus ay square plus az square. Divide करने के बाद what you will get is your unit vector. Yeah, what will remain will be a vector of magnitude 1 along the same direction of a bar. So if a bar happened to be 3 Newton along this direction, after dividing by 3 Newton, you'll be left with 1 along that direction. So that's why we divide by the magnitude of the vector. So the magnitude is taken out and we are left with the direction, or a unit vector along that direction. Okay. Any doubts? Is the length of the body diagonal confined to 2 specific points? What do you mean by that? Length of all the diagonals is the same. In this, length of all the body diagonals is the same. There are 4 body diagonals, जिनके tops are at respectively these 4 corners. All the body diagonals can, I didn't get your question, so just maybe you clarify again. Can I go to the previous slide and mark the body diagonal? ये था यार body diagonal. ये corner से दूसरे corner तक. This is another body diagonal. This is another body diagonal. This is another one. 4 body diagonal है. ठीक है. And one of you saying won't body diagonals length include AZ? AZ I cap कुछ नहीं, AZ K cap है first and foremost. I cap के along AX है और K cap के along AZ है. And won't the body diagonals length, अच्छा हाँ, you said that, won't the body diagonals length include AZ K cap? तो है ना, AZ है ना. अब AZ K cap is a vector. It's including, it's the vector's magnitude है ना इधर, AZ square. तीनों पे dependent है ना. If AX is 1 and AY is 2 and AZ's magnitude is 3, then the magnitude of this vector 1 I cap plus 2 j cap plus 3 k cap is going to be root 1 square plus 2 square plus 3 square. Okay. And what is A cap representing in the figure? So any A cap will always represent a unit vector in the direction of A bar. B cap will always represent a unit vector in the direction of B bar. So A cap is actually like this, a vector of magnitude 1 along A bar. Got it? Same direction as A bar. but magnitude 1. A cap is in a way going to carry our direction for us. Done with this page. Let me know. Okay. All right, try this. A bar is given to you as 2 I cap minus 3 j cap plus 6 k cap. Find the magnitude of this vector and find a unit vector parallel to this vector. So find the magnitude, find the unit vector parallel to this vector. Yes, the answer is correct. सही है. Yes, सही है, सबका सही है. Everyone's answering correctly. Good. Yes. Anyone needs more time, just say wait. सही है. Okay. Everyone answer is answered correctly. I hope who haven't answered are also getting it. सही है. Alright, so fairly simple. A bar is 2 I cap minus 3 j cap plus 6 k cap, which means the magnitude of vector A bar, which is basically A, is root 2 square. Just directly now apply your Pythagoras theorem. So apply a Pythagoras theorem on these coefficients. So root 2 square plus minus 3 ka square plus 6 square. 2 square is 4, minus 3 ka square is 9, 6 square is 36. In fact, that also tells us, of course, that this minus sign doesn't really matter. Okay, that minus sign doesn't really affect your uh, magnitude as such. All right, because anyways, even if you square that, that minus sign is going to disappear. So what you really should be focusing, whenever you see a vector, you can do this orally also. Whenever you see a vector, just focus on the numbers. वो numbers पे Pythagoras लगाओ. Root 2 square plus 3 square plus 6. So that's going to be 4 plus 9 plus 36. Root 49, which is just 7. Okay. One of you is asking 7 Newton. I didn't mention Newton in the question, so you'll not mention it in your answer. Okay. Just 7 then will be your answer. That's the magnitude, 7 units. As for the unit vector, A cap is A bar by A. A bar by A, you could have written it simply as 2 I cap minus 3 J cap plus 6 K cap divided by 7. Or you could have written it like this. ठीक है, अब ऐसा डाउट आना नहीं चाहिए ना. Come on, you know कि यार denominator common है, तो you can club the denominator. So both forms are correct. Okay? So A bar by A is this, and then you can also um, split that and also write it as 2 by 7 I cap minus 3 by 7 J cap plus 6 by 7 K cap. Exactly the same. Okay? Simple है. Unit vector निकालना, magnitude निकालना, given the vector itself. Okay? Anyone wants me to wait? Okay. एक सेकेंड. Cool. Now, next thing is we'll see how to convert from polar form to the given coordinate form. Okay. So now this time, this is a little थोड़ा ये diagram carefully समझ लो. यहाँ पे this vector is again the diagonal. I'll give more examples. Don't worry. ठीक है. ये these are all interrelated. सब अब और example आते ही जाएगा. ठीक है. Don't worry. But is this very clear? I mean, this is quite rudimentary. ये और इससे और करेंगे चीजें. Pretty clear है ना क्या किया हमने? बस Pythagoras लगाया on the numbers 2, 3, 6 पे Pythagoras लगाओ और यूनिट वेक्टर चाहिए तो उस वेक्टर को उससे उस नंबर से डिवाइड कर लो. ठीक है. अब उससे ही रिलेटेड है. If we want to go the other way, okay, let me zoom in first. I think थोड़ा converting from polar form to coordinate form in 3D. The polar form is when I'm giving you magnitude and angles. Remember, polar form when I give you magnitude and angles. अब rectangle के जब 2D होता था, तो it was always enough to give you angle with one line. Like if I tell you the angle with the x-axis is 30 degrees, that is always enough because you used to immediately realize that the angle with y-axis is 60 degrees. है ना? But in the 3D scenario, in a 3-dimensional scenario, things are not that easy. ऐसा नहीं है कि अगर वो x axis के साथ, imagine this is a random vector which is neither in the xy plane or the xz plane or the yz plane. ठीक है, इसे बीच से कुछ आ रहा है. So imagine कि you tie a rope to the corner of your room. ठीक है, this is the floor of your room, that's the front wall, that's the side wall. You tie a rope to the corner of that room and you're holding that rope. You're standing somewhere over here. ठीक है, and you're holding that rope in your hand. Okay, the way that rope would look, the vector is going to look. So can everyone now imagine this 3D vector? That's the corner of your room, floor, wall, side wall, and you're standing somewhere, okay? And you're holding that rope in your hand. So that's how the 3D vector looks. Now, that vector, that rope, happens to make an angle alpha with the x-axis. We're going to call this alpha. We're going to go in alphabetical order. We'll call this angle beta. The vector makes an angle beta with the y-axis. And the same vector makes an angle gamma with the z-axis. So that vector makes some angle alpha with the x, beta with the y, gamma with the z. They are not, the relation between them is not very straightforward as it was in 2D. 2D one angle was theta, other was 90 minus theta. यहाँ पे उतना स्ट्रेट फॉरवर्ड नहीं है. क्या रिलेशन है उनके बीच में हम आगे इसके थ्रू ही देखेंगे क्या रिलेशन है. बट फिलहाल है ना, it is important to specify all three angles, only then we get the full picture. So I have alpha, beta and gamma. I also have the magnitude of the vector. So this, if I'm given the magnitude and I'm given the angles, I'm ultimately given the vector in polar form. I'm given the magnitude and all the relevant angles. Now, to get the x component of that vector, I need to drop a perpendicular to the x-axis, and I need to find its component in the x direction. But what is its component? What is, you know, what is its part along the x-axis? What is that component? Isn't component found by taking the hypotenuse, and if your component is adjacent to theta, multiplying the hypotenuse with cos theta. अब इस केस में क्या हो जाएगा? Ax is adjacent to alpha, so Ax is a cos alpha. Any doubt in this equation? Okay. Similarly, Ay. So drop a perpendicular onto Ay. Okay. यहाँ पे we dropped a perpendicular onto the y-axis. This component is called as Ay. Okay. This is the y component of vector A bar. So this component is Ay. And how do I get Ay? Multiply the vector with cos of the angle it makes with the direction. So Ay is adjacent to beta. So Ay is a cos beta. Simple. And similarly for the other one, okay, one of you is saying for Ay, can we use a sine beta? No, because sine beta is going to be that one. Beta ki adjacent hai na? Ha, you cannot use sine alpha because now, please understand, these angles are not complementary angles. वो 2D के लिए था. अब ये एंगल सेम नहीं रहने वाला है ना? Just I hope you can imagine that. यार जो इस सिनारियो में, हाँ, इस सिनारियो में जो कॉम्प्लीमेंट्री है, as I start pulling this line out of the plane, as I start rotating this line towards you, as I start pulling it out of the plane, those angles are not going to stay the same, they're going to change. All right, so alpha, beta, gamma don't have any, they are not complementary angles. There's no straightforward relation between them कि इनका सब 90 है, वैसा कुछ नहीं है. We'll see आगे क्या relation है इनके बीच में. फिलहाल these are, है ना, they seem at the moment like three random angles. Okay, no nice relation between them. So Ay is a cos beta, and finally similarly Az, drop a perpendicular onto the z axis. This component is Az. Az is adjacent to gamma. Okay, it's not very clear from this diagram, just but imagine Az to just be found the way you found Ax. Okay, so Az is adjacent to gamma, so Az is a cos gamma. So जैसा Ax is a cos alpha, वैसे ही आया. Ay is a cos beta, Az is a cos gamma. Now that I have the x, y, and z components, I can directly now write the vector as something along I cap plus something along j cap plus something along k cap. So my vector becomes a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. हो गया, है ना? This is how we find it in coordinate form. Simple. A दिया है, angles दिया है, a cos alpha I cap, a cos beta j cap, a cos gamma k cap. That is your vector in coordinate form. Okay, the vector in coordinate form, the vector's component along the x-axis. So we know that the vector, like even if you're standing over here and the rope is coming towards you, you know that rope is in a way moving along the x. It's moving along the y, it's moving along the z, it's moving along these three axes. है ना? So that vector has an x component. It has a part along the x-axis which we found to be a cos alpha. It has a part along the y-axis which we found to be a cos beta. It has a part along the z-axis which we found to be a cos gamma. And that's it. There are no more parts. So a cos alpha, a cos beta, a cos gamma along I, j, and k. So this becomes your vector a bar. समझ में आया? If you're given these angles, given the vector, given the magnitude, this is what you'll do to get the vector in coordinate form. Simple. A cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. Clear है? समझा? Proven है, repeated. A cap फिर क्या हो जाएगा? A cap हो जाएगा a bar divided by a. A cap is vector divided by its magnitude. So now if you look carefully, the vector was a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. Okay. How is AZ equal to a cos gamma? You can't see it nicely in the diagram because it's a 3D diagram. If you're convinced AX is a cos alpha, AZ is a cos gamma. Jaisa AX was a cos alpha because A bar makes an angle alpha with the x-axis. वैसे ही AZ is a cos gamma because A bar makes an angle gamma with the z-axis. जैसा AX AY लिखा वैसे ही AZ भी लिख रहा है by extension. ठीक है? A bar makes an angle gamma with the z-axis. So its component along that direction is a cos gamma. Z is adjacent to gamma, so AZ becomes a cos gamma. Clear है? समझा? जिसने भी पूछा बता दो प्लीज. ठीक है? तो A bar by A is going to give me a cap. Dividing the vector by its magnitude will give me the unit vector. A bar by A. तो एक तो A से divide करने में A हर जगह कट जाएगा. And what will I be left with? Cos alpha I cap plus cos beta j cap plus cos gamma k cap. So that is interesting. If I'm given these angles and their magnitude, first of all, my unit vector only then depends on the angles. And interestingly, what is my unit vector? If I give you angles like this, if I give you the angles my vector makes with x, y, and z, what does that vector's unit vector become? Simply cos of that angle I cap, cos of the next angle j cap, cos of the next angle k cap, cos alpha I cap, cos beta j cap, cos gamma k cap. Yes, Smriti Rupa, yes. See, so that's how you find that unit vector. Very simple. Cos of the angles written in I cap, j cap, and k cap. That is your unit vector. Simple, eh? Let me know if you have any more doubts. Yes, examples आएंगे next page में. लिख के हो गया तो बता दो. Okay, Sama saying done. Is anyone saying wait? Nobody is saying wait. Okay. यहाँ पे अच्छा अच्छा अच्छा. So we'll do an example on that. But before that, before doing that example, एक small piece of information तुम्हें देना है. All right, so just one small detour before doing some example, because this we'll use this in that example. I want you to remember this golden rule. Key cos. So you know what supplementary angles are. I hope you know theta and 180 minus theta are, we refer to that as supplementary angles. जहाँ पे sum is 180 degrees. Complementary angles में sum is 90, supplementary में sum is 180. Okay, so now यहाँ पे क्या है? Cos theta is negative of cos 180 minus theta. मतलब cos of supplementary angles are negative of each other. So cos 120 degrees अगर कभी निकालना है, that is negative of cos 60 degrees. Cos 120 degrees निकालना है, तो that is negative of cos 60 degrees. Cos 60 degrees is half. Okay. Yes. Who's that? Yes, Mithika, yes. Cos 60 degrees is half. Okay, so because cos 60 is half, cos 120 का वैल्यू सडनली हमें पता है. क्यों? क्योंकि हमें ये याद है कि अब cos of supplementary angles are negative of each other. Cos 120 तुमने पहले कभी देखा नहीं होगा, but cos 120 कैसे निकालना है? बोल दो, it is the negative of cos 60. Cos 60 खुद क्या है? Half. तो cos 120 होता है minus half. अब जैसा cos के लिए ये रिलेशन है, sin के लिए ये रिलेशन है. Sin of theta is sin 180 minus theta. मतलब sin of supplementary angles are equal to each other. Okay, the sin 120 degrees is equal to sin 60 degrees. Sin 120 is equal to sin 60. Okay, so sin 60 is root 3 by 2. So sin 120 also becomes root 3 by 2. So those are just examples. For now, this stage at least want you to remember these two results. But yeah, now this is just a special case of the broader result. So there's a broader result which helps us figure out the sine and cos values of any angle, be it negative, be it positive, be it greater than 90, be it obtuse, be it beyond 180 as well. कोई भी एंगल का साइन कॉस हम निकाल सकते हैं by somehow relating it to the sine and cos of acute angles. Okay, you did it in calculus. Okay, very nice. Then that's good. Fine. बहुत जल्दी बता रहे हो यार कि you did in calculus. All right, great. You have done it in calculus. That's good. Nonetheless, I'll just tell you कि you can, if you want, you need not do this today or tomorrow, but maybe you can do it over this week, or you can do it over next week. But either way, before you finish vectors and calculus, if you want to watch these videos, if you want to know your basic trigonometry, which you may need for the next 2 years. Okay? So at any stage in the next 2 years, you may need, in fact, you would need trigonometry in almost every chapter. So normally, it's not an issue for the other students. It's not an issue for the JE students because they learn trigonometry in maths. But since some of you may not be taking this basic trigonometry in school as well, some of you may not be opting for maths in 11th and 12th. So for that case, I have my lecture notes on trigonometry. So I have 12 pages which you can go through. This is the same place where you can access your vectors lecture notes. वहाँ पे trigonometry का folder दिखेगा. So I have 12 pages, and those 12 pages are actually accompanying my lecture recording for trigonometry. So I wonder why I said 3 videos. This is just one video. Okay, so if you open trigonometry in your lecture recordings folder, the same place where you access vectors, वहाँ पे open trigonometry, you'll find one video watch it, make notes on it. Okay, so whatever I do in that slide is whatever I do over there, uske relevant notes can be found over here. Okay, so what's that? And I hope that's the complete lecture. I don't know why I've labeled it trigonometry 1. I hope that's a complete lecture. I'll look into it. But watch that. You'll need that anywhere across your course of physics. Okay? You just do one thing. Never mind. I'll do that later. Okay, cool. So with that, since you guys know the result, then there should be no harm in attempting this. Um, so trigonometry is so basically, no, don't include in the same chapter. Keep it separate because it's not related to vectors. It's something you will, in general, need across these entire 2 years. So actually, the idea is we have technically three concepts of maths which we will need in physics. One is vectors itself, one is calculus, and the third is trigonometry. The amount of trigonometry you need is not so big key we devote an entire chapter to it. Vectors, the amount you need, and calculus, the amount you need is quite big. So therefore, we have devoted chapters for that to start off our physics course. But the amount of trigonometry you need is not a lot. So as such, PACE never really schedules a lecture for it. But then what I've done is I have recorded one lecture which you can watch. Okay, so the notes for that are there on the drive, and the recording is there. Watch it and make separate notes and keep, and whatever formulas there, remember that for the next 2 years at least. Okay? Afterwards, you want to forget, you can forget, but at least for the next 2 years, remember that. Okay, so now I want you to solve this question. So क्या है, a vector of magnitude 5 makes angles 60, 135 and 120. 60, 135 and 120 with the x, y and z axis. Okay, I want you to find that vector in coordinate form, and I also want you to find the corresponding unit vector. Magnitude 5, angles with x, y and z are 60, 135, 120. Find the vector in coordinate form, them in I cap, j cap, k cap. Find the corresponding unit vector as well. Yeah. Sorry, I just checked the lecture which I've uploaded, trigonometry 1. There's only one lecture needed that covers everything. Yeah, so there's only one lecture. Um, let's see your answers. Girish सही है, वरुण सही है, भव्या सही है, कैनात सही है, गिरीश सही है, ओम सही है, गुड। स्मृति रूपा सही है। जस्ट फॉलो द फॉर्मूला, है ना? सो ए कॉस अल्फा आई कैप plus a cos beta j cap plus a cos gamma k cap. Those are your vectors. I mean that gives you your vector in coordinate form. And Bhavya saying the same thing. If you remove a, then just write cos alpha I cap, cos beta j cap, cos gamma k cap. You add them up. That gives you your vector in. That gives you a unit vector in coordinate form. This is alpha, beta, gamma. Okay? Angle with x is alpha. Angle with y is beta. Angle with z is gamma. Just apply the formula in the this is a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. That's your vector. अब बस cos of 135 लिखते वक्त, हाँ, you've learned this. So cos 135 is negative of cos 45. Cos 120 is negative of cos 60. Use those conditions. सही है स्मृति रूपा. Anyone wants me to wait? Anyone needs more time? Let me know. All right. So A bar is A cos alpha I cap plus A cos beta j cap plus A cos gamma k cap. That's a straightforward formula. What do we do with that now? A is 5 cos 60. Alpha is 60. The cos 60 degrees is half. So the first one becomes 5 by 2, 5 into half, I cap. The next one, cos 135 degrees is negative of cos 45 degrees. So it's negative of 1 by root 2. So if I multiply the magnitude with cos 135, I get minus 5 by root 2. And this shall be along j cap. For the last one, again magnitude 5, cos 120 degrees se multiply karna, which is negative of cos 60, which is minus half, as we saw in the previous page. So cos 120 is minus half. 5 into that will give minus 5 by 2 k cap. यहाँ से अपना वेक्टर आ गया I cap, j cap, k cap के फॉर्म में. Any doubts so far? Okay. Then please explain the second. ये line. हाँ, A is 5. A is 5. And cos alpha is 60. So cos 60 is half. So it becomes 5 by 2. 5 into half. I cap. Again, just substituting the values. A cos beta, j cap. So A is again 5. Cos beta. Beta is 135. Cos 135 is negative of cos 45. Supplementary angles. Second quadrant. Cos is negative. So cos 135 is negative of cos 45. Therefore, it's negative of 1 by root 2. So 5 into minus 1 by root 2 is minus 5 by root 2 j cap. समझ में आ रहा है? A cos gamma. Again, A is 5. Cos gamma, gamma is 120. Cos 120 is negative of half. तो ये हो जाएगा 5 into minus half, minus 5/2 k cap. अब समझ में आ रहा है कहाँ से आ रहा है ये सब? ओके एंड यहाँ पे so यहाँ पे this minus sign है ना, the magnitude, first of all these minus signs don't affect the magnitude of a vector. A vector is always positive. Pythagoras theorem का result is always positive है ना. So our magnitude does not depend on those minus signs, but those minus signs are there to tell us कि our vector moves opposite z, it moves opposite y. And that should make sense because, in fact, take the y-axis for example. Because it's making because it's making an obtuse angle with your y-axis, that's your hint key. It's moving its component ultimately is moving opposite y, right? Because it makes an obtuse angle with your y-axis. Similarly, because it makes an obtuse angle with your z-axis, whatever motion of it along, whatever part of it would be along the z-axis, that would be opposite z. ठीक है, x के साथ acute बनाता है, and therefore if you take its component along the x, it will be found moving along x. This part is moving opposite y, this part is moving opposite z. If I want the unit vector, then I just, instead of I can divide by 5 and get rid of this 5 because 5 is the magnitude पहले ही दिया है. Or what I can do is I can simply perform cos alpha I cap, cos beta j cap, cos gamma k cap. So directly half I cap minus 1 by root 2 j cap minus 1 by 2 k cap. That is my unit vector. Any more doubts? All right. कोई लिख रहा है? Anyone wants to say wait? Okay. Continuing the same idea. Now those angles have a very important name and very important property as well. Okay. So the cos of those angles that you just saw, cos alpha, cos beta, cos gamma, जो unit vector में appear होता है, cos of those angles that you just saw, they are given a name. The name is direction cosines. Cosines मतलब cos. Okay. And basically they're called as direction cosines because they appear in that unit vector which shows the direction. So the coefficients of the unit vector along a given vector are called its direction cosines. Called its direction cosines. Yes, so the coefficient of a unit vector along a given vector are called its direction cosines. What do we mean by coefficient? So by coefficient we mean, let me correct that. So by coefficient we mean जब उसको I cap J cap के फॉर्म में लिखोगे, कैसे दिखेगा वो? I cap J cap के फॉर्म में लिखोगे तो ऐसा दिखेगा cos alpha I cap, cos beta J cap, cos gamma K cap, ऐसा दिखेगा. तो वो जो coefficients है I, J और K का, cos alpha, cos beta, cos gamma, those coefficients are called your direction cosines. So your direction cosines are these three terms: cos alpha, comma cos beta, comma cos gamma. Those are your direction cosines. Even if the question ever asks you direction cosines and the answer also, they'll expect like this in this form: first term, comma second term, comma third term. Cos alpha I cap, sorry, cos alpha, comma cos beta, comma cos gamma. Only the cos term, don't put I cap over here. These are not vectors. These terms, the cos of the three angles, they are your direction cosines. The cos of the three angles are your direction cosines. Okay. Now, they are just cos of, they are numbers. They don't include any direction. This angle 30 है, so the first one is no sign, direction cosine. That's it. इसमें sign नहीं है. Direction cosine is cos alpha, cos beta, cos gamma. And this has a significance. Huh? This appears in that unit vector ka formula. Okay. These are what you multiply A with to get um, the components. You multiply A with cos alpha, with cos beta, with cos gamma to get the x, y, and z components. That's why these terms are important. Okay. These are your direction cosines. They are numbers. They can be positive or negative. Alpha acute at the cos alpha will be positive. Alpha obtuse hai, cos will be accordingly negative. Okay. Now, they don't include the direction of them. They are not vectors themselves, but they definitely carry the direction. यार एंगल दे दिया तो डायरेक्शन मिल गया, ये भी दिया तो डायरेक्शन मिल गया, तुम्हें बस सामने आई कैप जे कैप के कैप डालना है. डायरेक्शन कोसाइन तो उसका नाम में हमने वर्ड यूज किया डायरेक्शन. It doesn't need to be a vector to have the word direction in its name. Does it carry the direction with it? Does it in a way convey the direction? Of course it conveys. बस डाल दो इसके सामने आई कैप जे कैप के कैप, बन जाएगा अपना यूनिट वेक्टर. Direction cosine is just the name. That's it. Associate the name with cos alpha, cos beta, cos gamma. That's it. Okay. And if you place I cap, j cap, k cap along with that, in the right place, cos alpha, I cap, cos beta, j cap, cos gamma, k cap, you end up getting your unit vector. Okay. Now I'll explain this property in the end. But before that, in the question on page 20, in the previous page, we had these values for alpha, beta, gamma, 60, 135, 120. So what are our direction cosines in that question? Okay, what are our direction cosines? So our direction cosines, okay, our direction cosines are directly cos of these angles. So it's cos of 60, cos of 135, cos of 120. Cos of the angles will give you your direction cosine. Alright, so cos alpha, cos beta, cos gamma, those are your direction cosines. Cos 60 is half, cos 135 is minus 1 by root 2, cos 120 is minus 1 by 2. These three terms written in this order, they make up your direction cosines. Understood this example? This is how you'll find direction cosines if alpha, beta, gamma are given. No doubt. How do you find direction cosines if a question or if a vector is given to you the way it was given on page 17? Let's have a look at that 17. 17 में वेक्टर दिया था 2 i cap minus 3 j cap plus 6 k cap. My suggestion is उस वेक्टर से हमेशा यूनिट वेक्टर पहले निकाल दो. कैसे निकाला यूनिट वेक्टर? पहले वेक्टर का मैग्नीट्यूड निकाला, मैग्नीट्यूड निकालने के बाद यूनिट वेक्टर निकाला. We just saw this example. And फिर अब unit vector, once you know the unit vector, how can you find the direction cosine? Once you know this, in this example, what are my direction cosines? Very nice. The coefficients themselves. So not just 2 by 7. Okay, yes. So the coefficients themselves, 2 by 7 minus 3 by 7, 6 by 7, they are your direction cosines. Okay. So you can do it two ways. अगर angles दिया है तो angles का cos ले लो तो वो हो गया तुम्हारा direction cosines. या दूसरा तरीका है, अगर तुम्हें वेक्टर दिया है, वेक्टर से यूनिट वेक्टर निकाल दो पहले, और फिर यूनिट वेक्टर में जो तुम्हें कोएफिशिएंट्स दिखता है, रिमेंबर विद द साइन, वो कोएफिशिएंट्स तुम्हारा डायरेक्शन कोसाइंस होगा। 2/7 -3/7 6/7। ठीक है, so that's how you find direction cosines in these two types of questions. Now one important property of direction cosines, note ki we said our unit vector can always be written like this: cos alpha I cap, cos beta j cap, cos gamma k cap. Moreover, our unit vector's magnitude is always equal to 1. Unit vector's magnitude is always equal to 1. तो वैसा ही cos alpha I cap plus cos beta j cap plus cos gamma k cap, इस वेक्टर का भी magnitude will always be equal to 1. Okay, now इसका magnitude कैसे लिखेंगे? Pythagoras theorem, root cos square alpha plus cos square beta plus cos square gamma. This entire root is equal to 1. Agreed by Pythagoras theorem, root cos square alpha plus cos square beta plus cos square gamma is 1. But what if I square that equation? Then what do I get? So when I square that equation, I get cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is our relation between our direction cosines. So I said it wasn't as simple as one angle is 180 minus, or rather 90 minus the other angle. उतना simple नहीं है, पर फिर भी relation है. तीनों direction cosine का sum 1 होना चाहिए. Cross check over here. Is this giving this? दिख रहा है 4/9, sorry 4/49 plus 9/49 plus 36/49. That is 49/49. So इसका square plus इसका square plus iska square always has to add to 1. That is the property of those direction cosines. Unka square ka sum always must be 1. Verify for this as well. So 1/2 ka square. And I was carefully, I gave you these angles quite intentionally. You can verify ki these angles as a combination possible hai. 1/2 ka square 1/4 minus 1/√2 ka square 1/2 minus 1/2 का square 1/4 again. I'll explain that again. हाँ, तो यहाँ से ये पहले दिख रहा है कि कैसे वैलिड है इनका स्क्वायर्स लिया तो you get 1/4 1/2 1/4 and you add them up you get 1. Okay, so the property is saying कि उनका स्क्वायर्स का सम हमेशा 1 है. Okay, how am I getting that property? Let me explain that property one more time. तो basically अपना यूनिट वेक्टर ये था cos alpha I cap, cos beta j cap, cos gamma k cap. यूनिट वेक्टर का मैग्नीट्यूड मॉड हमेशा 1 होगा. मतलब ये जो हमने वेक्टर लिखा है cos कोसाइंस के टर्म में, उस वेक्टर का मैग्नीट्यूड 1 होने वाला है. ओके, नाउ how do I write the magnitude of a vector written in I cap, j cap, k cap form? Remember we just saw that some time ago. It's very simple. It's just root of ax square plus ay square plus az square. So it's root of cos square alpha plus cos square beta plus cos square gamma. That magnitude must be equal to 1. So root cos square alpha plus cos square beta plus cos square gamma is equal to 1. Square करके root हटा दो तो you get this important relation. Cos square alpha plus cos square gamma plus cos square beta is always equal to 1. Any other doubt? What if you saying if you don't square it also you get 1? Absolutely not. हाँ मतलब don't square it मतलब किसकी बात कर रहे हो? रूट वाले टर्म को स्क्वायर नहीं किया तो रूट cos स्क्वायर अल्फा प्लस cos स्क्वायर बीटा प्लस cos स्क्वायर गामा को वैसे ही लिखा. Is that what you're saying? हाँ ठीक है ना. But why write the root? That's like an additional step. This is a better equation, no? Root of this term will be like one extra step. Just squares का sum has to be 1. That's our property. Root भी लिखोगे तो भी मतलब सही रहेगा. Of course 1 का root 1 है. But this is the best way to look at it. Okay. So actually इसमें maybe I'll give an example for this. Let's take one example. Let me think of values which will work out nicely for you. Uh, okay. एक बड़ा a vector makes an angle of 127 degrees with the x-axis and cos inverse root 7/5 with the y-axis. Find the angle it could make with the z-axis. Alright, try कर लो. एक मिनट, इसको रूट पूरा रूट नहीं है, ऊपर रूट है. पूरा root wouldn't have existed anyways. Cos inverse of an input greater than 1 is not defined. वेरी नाइस वरुण, सही है. Okay, remember these angles are not independent. दो एंगल दिया है तो तीसरा एंगल मोर और लेस आ जाता है. स्मृति रूपा, इज दैट द ओनली आंसर पॉसिबल? सही है स्मृति. Molly, again, there are two answers that you can get. Two answers that are possible. Yes, सही है. Okay. Discuss करें. Are the others getting it? We need more time. सही है, but Saloni, you can get one more angle as well. Okay. Yeah, Smith. These angles are not random. So we know alpha as 127. We know beta. The minute you fix these two angles, then automatically the other angle can now only be one of two. We'll see why one of two different angles. So first and foremost, the angle relating all of them. Okay. So the equation relating all of them is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay. Now cos alpha is 127 degrees. Sorry, cos 127 degrees is negative of cos 53 degrees. So this term is going to be minus 3 by 5. On the other hand, cos of beta, cos of cos inverse root 7 by 5 is root 7 by 5. We don't know how to find sine of cos inverse, tan of cos inverse. We draw the triangle and all. But this one should be the easiest. Cos inverse root 7 by 5 is that angle जिसका cos is root 7 by 5. तो naturally उसी angle का जब cos लोगे, you will get root 7 by 5. Okay. Now ये जब तुम सब्स्टिट्यूट करोगे, -3/5 becomes 9/25. root 7 by 5 becomes 7 by 25. And then we are left with cos square gamma equal to 1. Cos square gamma becomes 1 minus 16 by 25. That becomes again 9 by 25. So cos square gamma is 9 by 25. Now this is where you have to be careful. Whenever you take this kind of root in maths, you should realize that cos gamma has two options. या तो cos gamma can be 3 upon 5 or cos gamma can be minus 3 upon. Okay, या तो 3 upon 5 या minus 3 upon 3 upon 5 वाला आंसर हमें पता है. We know that this is straight away 53 degrees. This one has to be, अभी यहाँ पे क्या है, एक मिनट sir, but it is cos square beta, so it should be cos क्या बाबा एक मिनट. First and foremost, cos beta is cos inverse root 7 by 5. Cos of cos inverse root 7 by 5 is root 7 by 5. Cos and cos inverse cancel out. They are opposite functions. Cos inverse root 7 by 5 अंदर लेके कुछ एंगल बाहर देगा. Cos वही एंगल लेके root 7 by 5 बाहर देगा. Cos of beta is root 7 by 5. उसका स्क्वायर लोगे तो हो जाएगा 7 by 25. Cos square beta is 7 by 25. Cos square alpha is 9 by 25. Cos square gamma is therefore 1 minus in दोनों का sum 16 by 25. Cos square gamma is 9 by 25. अब इसका रूट लेते वक्त है ना, पॉजिटिव रूट पॉसिबल है, नेगेटिव चेक कर लो, दोनों का स्क्वायर सेम चीज देगा. Square both of them. Am I not getting 9 by 25? Okay, so when you solve an equation, x square is constant. X has that equation has two solutions. X is root of constant and negative of root of constant. Okay, so cos gamma is 3 by 5 and minus 3 by 5. 3 by 5 वाला solution 53 degree है. A minus 3 by 5 वाला solution, we know angle can be from 0 to 180 only. So then minus 3 by 5 वाला solution has to be the corresponding obtuse angle. 3 by 5 आ रहा है मतलब is related to this, but it's 180 minus this. So it's 180 minus 53, just like we saw in the question itself. Okay, this angle is going to be 127 degrees. Sixteen इनका sum है, 9 plus 7 is 16. Cos square gamma is 1 minus 16 by 25. 1 minus 9 plus 7 by 25. उनको क्लब करके 16 by 25 कर लिया था. ठीक है, एनी डाउट प्लीज पूछ लो. समझ में आ गया? I would say I'll give you sums tomorrow, then you can solve on both of them and we can again discuss that on Tuesday. ठीक है, थोड़ा और इसको और आगे बढ़ा देते हैं. Today just revise the notes. In fact, if you want to do something today, I can say revise the notes and you can start watching that trigonometry lecture. You can maybe start making notes on that if you want to do that today, because you can relax. थोड़ा और इसको और आगे बात बढ़ाएंगे, and then put everything together and solve. So tomorrow we'll further use components to prove a formula let that go. Okay. Uh, we'll use components to further prove a formula, and then there'll be sufficient homework for this weekend. Okay, cool. Any doubts for today? Those who want to leave can leave. If anyone has any doubts they want to ask, can ask. You're welcome. Can I show previous slides? Which one? This one? 21, 20. The one with the formula. This one? Welcome. Before this, वही था क्या? ठीक. Okay. Bye.